All right, so we need to find the intervals of concave up of this function. So in order to do that, we need to first find the inflection point. So I'm going to start by deriving this equation. So in order to derive this equation, I need to do product rule because I have two functions here. So f is equal to x, g is equal to e to the 2x, f prime is 1, g prime of an e function is the exact same thing, and multiplied by the chain rule, the derivation of the exponent is just 2. So g prime is just 2e to the 2x, and then my product rule is f prime g plus g prime f. So f prime g, 1 times e to the 2x is just e to the 2x. G prime times f, so 2e to the 2x times x. So basically the derivation of this function, I can write it over here, it's just e to the 2x plus 2 times x is just 2x e to the 2x. Now I need to find the second derivative because you need the second derivative for your inflection point. So f double prime x. The derivation of e to the 2x, we just did it over here. The derivation of e to the 2x is just 2e to the 2x. That's your chain rule. And the derivation of 2x e to the 2x, again, I have to do product rule for this because I have two functions multiplying. So f is equal to 2x, g is equal to e to the 2x, f prime equals to 2, g prime equals 2e to the 2x. So now I can put f prime g plus g prime f over here. So f prime g is just 2e to the 2x, g prime f, 2e to the 2x times 2x. 2 times 2x is just 4x, and then I have e to the 2x. So that's g prime f. So this is my second derivation here. I can actually simplify it a bit because 2e to the 2x plus 2e to the 2x is just 4e to the 2x plus 4x e to the 2x. Now that I've found my second derivation, I can make this equal to 0 to find the x value of my inflection point. And now I need to solve this. In order to solve this, you need to common factor. My largest common factor is 4e to the 2x. I'm left with 1 plus x. An exponential equation never equals to 0, so there's no solution for this one. But over here, I know my solution is just going to be x equals negative 1. Now I simply have to put this on a number line, negative 1, and find my intervals of concave up and concave down. I'll start by picking a value slightly less than this. So I'll do f double prime of negative 2. And I'll do f double prime of a value slightly higher than this. So I'll do it for 0. So if I sub negative 2 into this equation over here, you can either use a calculator for this, or you can even kind of do it mentally. You know that e to any number is always positive. So this is going to be positive. 1 plus negative 2 is negative. So a positive number times a negative number is going to be negative. And if it's negative, it means this area is concave down. I sub in 0 into this equation. E to the power of 2 times 0 is just e to the 0, which is 1. So I have 4 times 1, which is 4. And then 1 plus 0 is 1. So I'm just going to have positive 4 over here. You don't actually need the value. Just need to know whether it's positive or negative. Your second derivation is positive. It means it's concave up. So for this question, my intervals of concave up are going to be from negative 1 to positive infinity.